Hi friends, in this video we'll be discussing the questions appeared in the GATE 2024 examination from the Transportation Engineering subject. So here we are going to discuss the questions from the Highway Engineering, the Railway Engineering as well as Airport Engineering. Okay. The first question is from Airport Engineering and it's a 1-mark question. The question is like this: as per the ICAO, the basic runway length is increased by X percentage for every Y meter raise in elevation from mean sea level. And finally, they are asking the values of X and Y. Okay, so we know that for the runway, we need to apply 3 corrections. The first one is the elevation correction. Second one is the temperature correction. And the third one is the gradient correction, right? And in the first one, the elevation correction, what it says as per ICAO is for every 300-meter rise above mean sea level, right? For every 300-meter rise above mean sea level, the correction should be 7%, right or not? So on the basic runway length, this much correction, 7% of basic runway length correction we need to apply, and that correction we need to add with this basic runway length, and that will be the updated length of the runway, right? So this is our direct specification as per ICAO. So from here, easily we are going to get option D as our final answer, right? It's a direct theory question. Now coming to the next question, it's from the Highway Engineering. This is also asked for 1 mark. The question is like this: a car is traveling at a speed of 60 kilometers per hour. So this is our first data. The speed of the vehicle is 60 kilometers per hour. And the next thing is it's traveling on a downward gradient of 2%. Okay. Now, the driver of the car suddenly observes stopped the vehicle on the car path at a distance of 130 meter ahead and applies the brake. And we know whenever a moving vehicle is seeing some obstruction, it may be applying the brakes and finally stopping, right? So somewhat they are asking the question related to the stopping side distance. Generally, we call it as an obstruction, but here they told that it's a stopped vehicle. Many students got confusion after seeing this, the term, the stopped vehicle. But in classes, already we have explained that a stopped vehicle is considered as an obstruction, right? Obviously. Now they have given that it's at 130 meter ahead. So let it be there. Sometimes we may not be requiring that data. Now, if the brake efficiency is 60% and the coefficient of friction is 0.7 and the driver's reaction time is 2.5 seconds. Okay, acceleration due to gravity is also given 9.81. The distance required by the driver to bring the car to safe stop lies in the range. So finally, they are asking the stopping side distance. That's it, SSD. So we know the equation of stopping side distance. Either you can use the equation in terms of meter per second, which is nothing but v square by 2g. See here, they have given the brake efficiency, which means, first of all, we need to multiply the coefficient of friction with the brake efficiency. And also they told that the car is traveling on a slope of downward gradient, right? Which means we need to substitute minus gradient value here, right? Either you can use this equation or the kilometer per hour for the equation you can use the 0.278 Vt, where this V is in kilometers per hour. V square divided by 254 eta f minus G percentage by 100. So any equation you can use, just directly substitute, you'll be getting the value. Definitely there will be a slight change between these obtained answers. Maybe that's why they might have given the range as the options. Okay, so here everything is available. Let me use the second equation. This is equal to 0.278 into the speed is given as 60 kilometers per hour. 60 into the reaction time is 2.5, right? 2.5 seconds. Now the first part is over, which is nothing but the lag distance. Now plus 60 square divided by 254. The brake efficiency is given as 60%. For you need to substitute 0.6, right? Into F value 0.7 minus. The reason why I have written the gradient in this format is we know we need to substitute this value in terms of or in the form of decimals, right? We need to substitute in terms of decimals, which means 2% indicates. See, if I'm writing in this way, 2 by 100. That is nothing but, right, G percent by 100, which is nothing but 0.02, right or not? So once you do this, you're going to get around 88. I'm sorry, just a second. You will be getting around, 77.1, right? I'm not writing separately. So 77.1 meter approximately you'll be getting. If I'm going back to the range, yes, in this range we are getting, right? 75 to 79, which means option D will be our final answer. Okay, so right now I have used this second equation, which is in terms of kilometers per hour. If you want to use the first equation, then what change will come? Only thing is, we need to substitute this G value, which is given in the question 9.81 there. And the other thing is we need to substitute to meter per second. How to do that? Just a 60 into 5 by 80. Okay, so whatever value you are getting, directly you can substitute for this in place of V. Okay, so here and here it's in meter per second. And in this equation, if you are using in both places, it's in kilometers per hour. That's why I have directly substitute 60 kilometers per hour. Okay, I hope you got the point. That's it. Moving to the next question. This question is from railway engineering, which is asked for 2 marks. Somewhat an easy question. Now, what they have given is a set of trains which are using a railway track, which is a broad gauge railway track. That's a keyword here, and having 437-meter radius. Okay. Now, finally, what they are asking is the required equilibrium curve. We know the super elevation which is provided, or the actual super elevation which we are going to provide it on the road, is actually called as the equilibrium super elevation, right? And we know the equation GV square divided by 127R. This is the equation where this G is the gauge distance. They have directly given that value as 1750 mm. Even if they are not giving the value in any upcoming exams, then also we need to substitute the value 1750 mm or 1.75 meter for the broad gauge track, right? This is why I told you this is the keyword. Okay, now directly substitute the value, which is equal to 1750 mm. See, if we are substituting the value of G in millimeter, the obtained answer also will be in millimeter. If I'm substituting like 175, means 175 centimeter, then the obtained value will be in centimeter. So on, right? Similarly, if I'm substituting like 1.75 meter, then for the obtained value will be in meter. Okay, so here they have asked the answer in millimeter. That's the reason why I'm also substituting G in millimeter. Okay, now into here, what value we need to substitute? We have to substitute the average value of the railway track, which is not given in this question. Instead, they have given a data like this. From here, we need to calculate the average speed of the railway track. Okay, so let it be there as of now, divided by 127 into radius. How much it is? 437 meter. Okay, now all the data required in this question is available except this average speed. Now, how to calculate the average speed? When they are giving the numbers with the corresponding speeds, or the speeds of the various trains, various number of trains which are using the track, we need to calculate the weighted average, right? How we are going to calculate the weighted average? There are 20 trains which are running at a speed of 40 kmph, and there are 15 trains which are moving at a speed of 50 kmph. Similarly, 12 trains at 60, 8 trains at 70, and finally 3 trains traveling at 80 kilometers per hour. Okay, now all these trains are having their own speeds, so we are just multiplying with their corresponding numbers, so that what we need to do, we need to divide with the total number, right? So 20 plus 15 plus 12 plus 8 plus 3. This is what we mean by the weighted average when they are giving the multiple numbers or the corresponding quantities of various values. This concept we can use in many contexts, not only for calculating this average speed, for anything, right? Weighted average we call. Now, once you do this calculation, you are going to get around 52.93, obviously in kilometers per hour, because all these given values are in kilometers per hour, right? It's very important to note that here also we need to substitute the value in kilometers per hour. So no need to change now. Suppose if they were giving the values in meter per second, then the obtained value also will be in meter per second. No? So we need to convert that to kilometers per hour before substituting to this given equation. Okay. So here, once I'm just taking this value 52.93 here in this equation, finally we are going to get 88.34 mm. Okay, they are asking us to round off to integer, so approximately we can round off to 88 millimeter. Okay, so that's going to be our final answer, 88 millimeter. Okay, so I hope you got the concept. Now moving on to the next question. This is a question asked from the highway engineering from the payment design chapter. Somewhat a lengthy question, lengthy in the sense the data was lengthy, but the calculation was actually very simple. And it's asked for 2 marks. Okay, so just look at the question. First of all, what they are finally asked. They are asking us the cumulative standard axles in MSA, which means from this term itself, we need to understand that the question is from the modified CBR method, right? We're having the unique unit of cumulative standard axles. We can call it as CSA also, and we generally represent in terms of million standard axles, MSA. We know that, right? So it's a question from the modified CBR method. So whenever we get question from modified CBR method, we need to think about the design traffic equation, right? 365 ADF into 1 plus R raised to M minus 1 whole divided by R, right? And all these terms you should be knowing. A is nothing but the anticipated traffic. D is the lane distribution factor. F is the vehicle damage factor. R, which is there in the denominator as well, which is nothing but the annual growth rate of vehicle. N is nothing but the design life. That's it. 1 is just a constant. That's it. We know that. Okay. Now, while substituting these values, we know all the values which are required in the equations are not available in the question. Instead, they have given some other data to find those unknown values, right? So first of all, look at this A, anticipated traffic, whether they have given it or not. They have given a data which is actually 800 per day, which is what? The following data is obtained at an axle load survey, which means this value is what is observed during the survey, right? But what we require is the anticipated traffic means what? At the end of road construction, what will be the future traffic? That's what we require, right? So look at the data. What they're telling, how many years will be required for constructing the pavement? For a period of 5 years from the date of survey, which means what? At the date of survey or on that day of survey, we are having 800 vehicles per hour. We generally use the unit commercial vehicles per day or CVPD. What we require is at the time of the, what I can say, whenever we are opening the road to the public or at the time of completion of construction of the road, what will be the traffic? That's what we need to substitute in place of this A, right? So let's calculate that A first, then we can come back to this equation. Okay, so that's A is nothing but P into 1 plus R raised to X, where P like a compound interest equation. We know that we have discussed many questions like this in the class as well. So the P value is nothing but 800 and 1 plus the required, the annual growth rate is already given in the question as 4%. We need to substitute as 0.04, right? And 5 years is nothing but the construction period. Now, once you are doing this calculation, you're going to get it as 973.32 commercial vehicles per day. So generally, we don't use to round off the value. Yes, if you are rounding off 973 or 974, you can take, but generally we don't used to do that. We substitute it directly here. Okay. So 973.32. That's it. So A we have substituted. Now the next thing is D. Is nothing but the vehicle distribution factor, lane distribution factor, we can say. That depends upon the number of lanes on the road. But here they have not given the number of lanes. So in any question, if the number of lanes on the road is not available, generally we assume that the number of lanes on the road as 1, or it's a single lane road, right? 1 lane or single lane road. And we know that the lane distribution factor for a single lane road is nothing but 1 or 100%. So since the data is not available in the question, we are assuming like that and moving forward. D is equal to 1. That's it. The next thing is F, nothing but the vehicle damage factor, which is also an unknown. In this question, they have not given it. But they have mentioned that the equivalent wheel load factor and vehicle damage factor are equal, which means what? We need to know what is the meaning of this equivalent wheel load factor. And we know that the equivalent wheel load factor is nothing but any load divided by the standard load, which means the equivalent wheel load factor we are going to calculate for a particular load, right? For every load, we can calculate different values of equivalent wheel load factor. So if you're having a load, then divide by the standard load raised to power 4. If you are doing this, we are going to get the equivalent wheel load factor for this particular load. Okay, like that. Now, how much will be the load which we need to take here? For that, they might have given a data. Look at here. They've already given the axle load is 12,000 kilogram. Okay, that's what they have given. So we need to consider that 12,000 kilogram for calculating the equivalent wheel load factor and substitute in place of D, right? But the standard load we don't know. Generally, we used to take 8,200 kilogram. But in this question, they have already mentioned in the question as 8160 kilogram. So once they are taking, once they are giving any value in the question itself, then we shouldn't assume anything, right? Just take it as it is. Both the load values should be in the same unit, then only it will get cancelled, raised to 4. Once you are doing this, you are going to get 4.67. That's it, a unitless value. Taking into the equation 4.67. Why? Why we are taking like this? They told that the vehicle damage factor, which is nothing but F in the equation, is equal to the equivalent wheel load factor. That's why we are taking that F is equal to this 4.67. Got it? Now we have completed 365 ADF. Now what is remaining? 1 plus R raised to N. We know rate is already, we have used here also the same rate, 1 plus 0.04, which is nothing but 1 plus R. Now raised to N. N is nothing but the design life, which is given as 15 years minus 1. That's it. Got it? Now whole divide by, once again, what we need to do? We need to divide with the growth rate, R value, which is nothing but 0.04. That's it. Got it? Now once you are doing this, do this calculation, you're going to get a very big data actually, right? A very big value you're going to get. That is what is in terms of cumulative standard axle, CSA. So we'll be getting around 33.22 into 10 raised to 6, right? A very big value you're going to get. So this big value we used to represent in terms of CSA, cumulative standard axles. We can also write it in terms of million standard axles by dividing the value with 1 million, which is nothing but 10 raised to 6. So this much million standard axles it will be, which is nothing but 33.22 MSA. That's it, million standard axles. So here 33.22 is what we are getting as the final answer. So going back to the question, they are also asking us to round off to 2 decimal places. So that's it, 33.22 will be the final answer. Okay, so there were a lot of things to be done here, but actually the calculations, everything was simple. But rather than giving the data directly, they have given some other terms also to incorporate with the given data. That's it. Okay, so I hope you have got the concept. Yes, well enough. They have given 2 marks also for the question. Okay, moving forward to the next question. This question is also from the highway engineering subject. The concept of summit curve. Okay, so what they are asking in the question is to calculate the length of the summit curve. And we know the length of the summit curve. To calculate the length of the summit curve, we require 2 data, stopping side distance and overtaking side distance, right? The length based on SSD we need to calculate. The length based on OSD we need to calculate. Whichever is maximum, that will be the final answer or the minimal length of the summit curve. but generally they don't used to ask that much lengthy question. If they are asking the question, I mean, if they are giving the data regarding stopping side distance, we used to calculate based on that. If they are giving the data for OSD, we'll calculate based on that. This is what generally used to happen in the GATE examination. We have discussed that in the question, I mean, in the classes as well. But suppose if they were giving the data for OSD also, SSD as well as OSD, then of course it's going to be a lengthy problem. Okay. Now here from the question, it's very clear that they are asking you the question based on, the stopping side distance. It's clearly mentioned. Suppose if this was not mentioned, then also we are going to do the same because the given data is for stopping side distance only, right? So we know the equation of the length of summit curve for stopping side distance, ns square by square root of 2h plus square root of 2 small h the whole square. Okay, so symbols, we can use any symbol. If I'm using a symbol, I should mention what it means, right? So here n is nothing but the deviation angle, but they have not given the deviation angle in the question. So first of all, calculate that. N, the deviation angle is nothing but the first gradient, which is nothing but 3%, which is positive value, minus the second gradient, which is nothing but minus 5%. So minus minus will become plus. We are going to get 8%. That's it. But we are not going to substitute the percentage value here. It's going to be 0.08. That's it. That. The next S, what we mean by S is nothing but the sight distance. Either it can be stopping side distance or it can be overtaking side distance. But in this context, definitely it's going to be stopping side distance. But they have not given that value in the question. Whether they have given? No. Instead, what they have given? They have given all the data for calculating the stopping side distance. Okay, so that is the next task for us, calculating the stopping side distance. According to this equation is nothing but yes, right? So calculate that and substitute here back. Let it be there as of now. I'm just leaving the space there. Now let's talk about capital H and small h. Capital H is nothing but the height of eye level of the driver, which is given in the question as 2.3 meter. This is nothing but our H value. Small h is nothing but the height of the obstruction, which is nothing but 0.35 given in the question. So that we can substitute here. Square root of 2 into 2.3 plus square root of 2 into 0.35, like 0.7, like that also you can write. Just for understanding, I'm just writing completely. That's it. So whole square. Now the only task is to calculate the stopping side distance and substitute here. And don't forget to put the square. ns square by square root of 4.6 plus square root of 1.7 all square, like that. Okay, now our real task is to calculate stopping side distance. So let's do it. We have already, discussed one question for stopping side distance. So you can use any equation, 0.278 VT, which is nothing but 80 kilometers per hour. Look at the data. They have given the reaction time as well, right? 2 seconds. Suppose if it was not given, then by default we need to consider 2.5 seconds as per IRC. But since it is available there, given in the question, then we shouldn't assume any value, right? So don't make such a silly mistake and lose your mark. So into 2. So this is nothing but 0.278 VT, the lag distance, plus the braking distance, V square divided by 254 F. F is how much? Given in the question as 0.36. Right or not? So in another question where we have discussed the stopping side distance, we were having too many things here, right? Eta F minus G% by 100. Like this we have written. Why? Because they have given the efficiency and also it was on the gradient. That's why. Here it's on a, summit curve. We don't use to consider the gradient while calculating stopping side distance on summit curve as well as valley curve. Okay, that's a standard assumption by IRC. Also, they have mentioned here, right? The stopping side distance is compensated on gradient, which means we don't have to consider the gradient in this, in the calculation of stopping side distance on the summit curve as well as valley curve. So that's an important point to be remembered. The efficiency is not given in the question, so by default it's 100%, which means equal to 1. That's the reason why we have not written any efficiency term here. Okay. Now once you are calculating it, you're going to get the stopping side distance around 114.47 meter. Now substitute this value back to the main equation, 114.47. Now you're going to get the answer as 117.93, right? 117.93 meter. That's it. Now here there is an important check here. What is the check? Whenever we are using this equation, we are having an assumption, right? So what is the assumption? That the length value which we are going to calculate is greater than or equal to the stopping side distance. This is the basic assumption, which means 117.93 is the obtained value of L, and the stopping side distance is 114, which means our assumption is correct, right? The obtained value is 117.93, will well greater than stopping side distance 114.47, which means our assumption was correct. So it's okay. The calculated value will be the final answer. That's it. Okay, guys. So suppose if this assumption is becoming wrong, which means the calculated length value is becoming less than this stopping side distance, then what we need to do? We need to ignore this calculated value of length, and we need to use the next equation, 2s minus square root of 2h plus square root of 2 small h whole square by m. So this equation we had to use, and the obtained value would have been our final answer. But here it is not required. Okay, in this question it is not required. Why? Because our assumption was already correct. That's it. Okay, that's it. It was a 2-mark question. So what a very good question asked in the exam. Moving forward, the next question is also from the, it's from the railway engineering. And the question is of 2 marks. So let's read the question first of all. The maximum restricted speed, that's what they're asking. Okay, so we know in the railway track concept, the superelevation of railway track, we are having 2 different, what I can say, the superelevation values, right? One is the theoretical superelevation value. The other one is the actual superelevation value, which we also call as the equilibrium, right? We have already done one question for this. The difference between these two is nothing but our Kant deficiency, or the deficiency of superelevation, right or not? Yes. So this is our basic equation. And the value which they are asking, the maximum restricted speed, it's somewhat related to this theoretical superelevation. We know that, right? How to calculate it? The symbol, generally we use E, not G, okay? It's E, let it be. Okay, hope you got it. Now this is nothing but the gauge value G into Vmax square divided by 127 R. So this Vmax is what they are asking in the question, right? The maximum speed. Now this equilibrium superelevation, how to calculate it? G into V average speed square by 127 R. You just take the difference between these two values, you are going to get the Kant deficiency, right or not? So we have already done a question for this actual superelevation calculations and all. We know how to calculate it. And look at the data. What all data they have given? They have mentioned the radius of the curve, right? 1080 meter. It's a broad gauge railway track, which means by default we need to take G as 1750 mm. Already we have discussed that in another question. Okay, suppose if it was not given in the question, then also, I mean, in the previous question it was given in the data already 1750 mm. Even if it was not given, then we need to substitute. I mean, we need to assume and substitute the value 1750 mm. Okay. Now coming back to the equation, to calculate this average, I mean, to calculate the equilibrium superelevation, they have already given the data in the question, so that we can directly substitute and calculate it. First of all, it's going to be 1750 into the speed value is 70, so 70 square by 127 into the radius is given as 1080, right? So minus, so this value is also 1750 into this Vmax is what we need to calculate. Vmax square by 127 into 1080. Okay, all remaining values will be same except this speed values, right? One is maximum, the other one is average. is equal to the current efficiency they have given as 10 centimeter, right? So what is the meaning of this? The difference between the theoretical superelevation and actual superelevation is 10 centimeter, which means the values which we need to substitute here should be in centimeter only, right? So can we substitute 1750? No, we need to substitute 175 here, 175 here. Or else what you can do, just keep that 1750, no issue. What you can do, the only thing is the obtained value will be in mm, right? So these values, definitely it's going to be in mm. This also will be in mm, right? So what you can do, instead of putting 10 to the right hand side, you can keep it as 100. That's it, 100 mm. Simple, right or not? So once you're solving it, you're going to get the Vmax as approximately 112.85 kilometers per hour. So we can round off to 113 kilometers per 112 or 113, whatever. Okay, because they are asking to the integer, nearest integer value. So we are rounding off to the integer 113 or 112. Both you can put, no issue. Okay, so that's it. That was asked for 2 marks. So always remember this value. Suppose if they are not giving the data in the question, we always have to substitute 1750 mm as our gauge value, which is called as the dynamic gauge of the railway track. Okay, so that's it. Now, moving on to the next question, somewhat a very easy question, direct theoretical question. As for 1 mark, again from the superelevation concept. In general, the outer edge is raised above the inner edge, which means what? Which is nothing but the superelevation. So the superelevation is provided on which of the given situations? We know that it's on the highway as well as railway. That's it, not on the taxiway. Okay, so the superelevation is generally given for counteracting the effects of the centrifugal force, which is required for highways and railways actually, right? Not for taxiways. So here option C will be our final answer. A direct theory question, that's it. Moving forward, the next question is actually from the highway engineering related to the highway materials. It's an MSQ question. What they have asked is in context of the payment materials characterization, the correct statements is or are, which means in this given statements, we need to pick the correct statements. It's an MSQ question, which means more than one can be correct. Sometimes only one may be correct, sometimes more than one, like that. So look at the first statement. The toughness and hardness of road aggregates are determined by Los Angeles abrasion test and aggregate impact test. Yes, it's correct, right? Los Angeles test is used for hardness and aggregate impact test is used for toughness, right? Correct? Is it correct? No, it's incorrect. Why? Because Los Angeles abrasion test is used for hardness and aggregate impact test is for toughness. It's in the opposite order, right? They have just changed the order to confuse you, right or not? If the order was different, I mean the exactly opposite, then it would be a correct answer. Okay, so this statement is absolutely wrong. The second question, the load penetration curve of CBR test may need origin correction due to the non-vertical penetrating plunger of the loading machine. Yes, that's a correct statement. We know that, right? If the plunger is not exactly placed vertically, then we know that the graph, instead of going like this, the graph will be going somewhat like this, right? So there will be an initial concavity. This is called as initial concavity. So in such cases, in case of the initial concavity, then we need to give some correction. The origin correction we need to give. Origin correction means at this point where we are having the initial concavity, right? Then only we'll be getting the accurate values. Okay, so this statement is correct. Okay, now in compacted bituminous mix, the voids in mineral aggregate is equal to the sum of total volume of air voids and total volume of bitumen. Yes, it's obviously correct. That's what we are doing in the Marshall bituminous mix design and all. Percentage VMA is nothing but percentage VA plus percentage VB, which this percentage VA is nothing but the percentage air voids and percentage VB is nothing but the volume of bitumen. That's it. So this is also the right statement. The final statement, grading of normal bitumen binder is done based on viscosity test results. Yes, this is also true. We know for the, grading, we are having penetration test. So this also can be used actually. Penetration test. Also, we can use the viscosity test, right? This penetration grading was previous practice. Previously, we were using this penetration grading, but nowadays we are not. We have replaced that penetration grading with the viscosity grading, right? This is what we are using right now. And we are having 4 grades, VG 10, 20, 30, and 40. We know this, right? So this statement is also absolutely correct. So according to this given order, B, C, D will be the final answer. Maybe in your question paper, the order might be different. Whatever, we can just look at the given statements, whatever it's B, C, D or A, B, C, whatever. Look at the statement just, okay? The order of the given statements might be different in the actual question paper. So according to this question order, then B, C, D will be our correct statements. That's it. Okay, so they have given 2 marks for this question. Moving forward to the next question. This is from the highway engineering, from traffic engineering chapter. They are asking us the free means, the question is like this, the free mean speed is 60 kilometers per hour. The average space headway at jam density on the road is 8 meter. The maximum flow is what they're asking. See this concept, I don't know how many times we have, discussed this concept in the classes. That many times they have asked in the examination also, right? So many times repeated concept. This is direct question, direct question, direct question. Okay, lots of times asked question, and they have given 2 marks as well. And we know the equation of the maximum flow is nothing but Vf into Kj by 4. This is our equation. We know that. Now Vf, free flow speed, Vf, they have given in the question, it's directly as 60 kilometers per hour. Free flow speed or free mean speed, we can call anything. But kg is not given in the question. Instead, they are told that the spacing at jam density is 8 meters. So that we should know the relationship between the density and spacing, right? See, it may not be always kj. It can be simply k, right? The density k is equal to, density k is equal to 1000 by space headway, or in other words, in the opposite way also, space headway is nothing but 1000 divided by the density k. Okay, they have told that the spacing 8 meter is happening when the road is at traffic jam, right? So this 8 meter is corresponds to the traffic jam, right? So which means the obtained density also will be the jam density. So kj is going to be then 1000 by 8. That's it. Now we don't have to substitute this accurate value here. What we can do, directly just substitute that 1000 by 8. So 60 into 1000 by 8, that's it, divided by 4. So you do this, exactly you are going to get 1875 vehicles per hour. That's it. Okay, you can separately also calculate. You will be getting 125. I'm telling sometimes it may not be coming like an integer, right? So if it is not coming as an integer, so better don't calculate it, like in a decimals and substitute, round it off and substitute here. Whatever you are getting, suppose if you are getting some point, something like that, then that points also, or that decimal values also, you substitute in this place, so that the final answer will be very accurate. So here the answer is going to be option A. That's it. See how simply you're getting 2 marks. This is also asked for 2 marks. Hope you got the point. Okay, shall we move on to the next question? Yes. Okay, so this question is from the airport engineering. They're asking us the effective gradient, right? In classes also we have done questions, similar questions, right? Table, we have drawn the table and we have calculated effective gradient. So I hope all of you might have got it already, right? Now, to calculate the effective gradient, first of all, we need to know the concept, what we need to do. Suppose if you are having a ground somewhat like this, okay, let me just a rough sketch I'm drawing. Effective gradient means the elevation difference between the highest point and the lowest point. First of all, we need to take that. So this highest and lowest can be anywhere in this stretch from the starting point to end point. It can be anywhere. It can be at the starting point. It can be at the end point. It can be intermediate anywhere. So you just take the difference between the highest point and the lowest point. That's the first task. Okay, so this is it. And you need to divide with the total length from the starting to the ending. Whatever be the total length of this stretch, we need to consider that to calculate the effective gradient. Okay, so to check this horizontal length, what we can do? Just go back to the table and look at this value 0 to 200, this gradient, 200 to 600, this gradient, so on, so on, so on, so on. Finally, what they are telling, 1600 to 2000, the gradient is minus 0.5, which means what? The entire length will be 2000 meter or 2 kilometer. That's it. So this is an available data. What we need to do is to calculate the difference between the highest and the lowest point. Okay. Now for that, just go back to the given table. What they told is, for the first 200 meter, the gradient is 1%, which is positive, which means what? The ground is moving upward. Let me just take a reduced level of 100 meter here, just as an example. Okay, we can take 0 meter also, anything like a benchmark, which you have studied in survey. I'm just taking 100 meter, let it be. Okay, here already they have given us 100 meter and all. Okay, fine. It's not mandatory to take 100 meter. Okay, it's just an assumption. Now, for the first 200 meter, like horizontal 200 meter, for 200 meters distance, the ground is having an upward slope of 1%. The slope is actually 1%. Means what? How much will be this height then? The slope is 1%, means what? This tan theta is 0.01, right? If I'm just taking the tan theta, the slope is 0.01, which means what? This height, if I'm just putting h1, this height divided by this horizontal distance 200 meter is nothing but 0.01, which means what? h1 will be 0.01 into 200 meter. This is the meaning, right? Then how much will be h1 then? That's going to be 2 meters, simple. Which means the ground level was at 100 meter initially, and now it will become 1 or 2 meter. After a rise in gradient, it will become 1 or 2. Suppose instead of this 100 meter, if you are substituting it as 0 meter, you are assuming it as 0. Okay, fine. Now the ground might have reached at 2 meter. That's it. So this 100 meter is just like a benchmark. That's it. Okay, we know that in survey. So we got the elevation of the second point, or after 200 meter, it has reached at 1 or 2. Now, from 200 meter to 600 meter, the gradient is -1, which means what? Now, the ground is going downward. For how much distance? 200 to 600, which means 200 to 600 means what? This stretch is going to be 400 meter, right? 200 to 600 means 400 meter. So for 400 meter, the ground is coming downward. The gradient is negative 1%. Right or not? So this gradient is also 1%, but it is negative. Now, what is the meaning of that? Again, I'm taking the tan theta value, again the slope. Okay, so that is also 0.01, which is going to be, I just want to know that reduction. See, I have just drawn, I don't know where it is. It's sometimes coming down, or it may be again going up somewhere. So 0.01 is going to be the next elevation change by 400 meters. So that this H2 is going to be 0.01 into 400 meter. How much you are going to get? 4 meter. What is the meaning of this? In next to 400 meter, the elevation has changed by 4 meter. But this 0.01 is negative, no? -1%, which means -4, which means from the second point, which was at 1 or 2 meter, in the next 400 meter, the ground level has decreased to a value of, decreased by 4 meter. That's the meaning. Which means what? The ground might have reached somewhere here. Right or not? So from 1 or 2, it has reached 100 and again down, which means it will be now at 98 meter. That's the meaning, right? This 4 meter. This is what we have calculated right now, minus 4 meter. Understood, guys? So like this, again, we can calculate for the next 600 to 1200, which means for the next 600 meter, it's again going upward by a percentage of 0.8. And in the next 400 meter, again, it's going upward. And in the next 400 meter, again, it is coming down like the second one, like that, like that, like that. We will be getting the reduced level of the final point as well, like this. So look at this. This is what we have taken initially. Okay, this you can take as the reference also. Okay, no need to take at a height 100 and all. Fine. And this we have calculated 102, and this we have calculated 98. And similarly, you calculate, you will get these points as well. Okay. Now, finally, what is the meaning of this effective gradient? As I told you, the highest point, which is 103.6 meter, minus lowest point, which is at 98 meter, divided by the total length, 2000 meter. So into 100 you do, you are going to get directly in percentage. So once you are doing it, you are going to get 0.28 percentage as our effective gradient value. Got it, guys? Going back to the options, they have given option A as 0.28. So here option A will be our final answer. Okay, so I hope you got the concept. So don't get confused in this particular figure, which I have already taken before. Here they have taken a height 100 meter. Not required. Okay, if you're simply taking the first point as 100, then also we are going to get the same value. See, already we have obtained that 102 and 98 here. No, similarly. Got it, guys? That's it. So option A will be the final answer here. So they have given 1 mark for this calculation. Yes, we have to do a little bit, little bit calculations of what lengthy it is, but still it's what easy, right? It's not difficult calculations. That's why they have just given 1 mark. Okay, right. Now moving forward to the next question. This question is also from highway engineering chapter. It's a direct question, direct theory question. That's why they have given just 1 mark. Okay, so let's read the data first of all. The question is finally what they are asking is the stress combination. How will be the stress combination? So I hope you might have already gone through this concept of warping stresses or the temperature stresses, right? Warping stresses and frictional stresses. So these two are the temperature stresses we are having, and also the wheel load stresses, right? The wheel load stresses. In flexible pavement, we will be having only the wheel load stresses. In rigid pavement or cement concrete pavement, we will be having temperature stresses as well. They have given the slab sizes, but we don't care. We don't require the slab size to calculate this, okay? Because they are not asking us to calculate the value. They are just asking us the combination. So the critical stress combination during summer midnight, this is what we need to find ultimately. See, directly from the options, we are going to get option B, right? Why? Why? If we have prepared just within a fractional second, you are going to get the answer. Why? We know at midnight, we don't use to take the combination of friction, right? The frictional stresses or the frictional stresses, we don't use to consider for the combination of, the combination at midnight, right or not? So here in all the options A, C, as well as D, they have given the combination of frictional stresses. There is only one option in which the frictional stress is not there, which is option B. So which means the final answer is going to be option B directly, right or not? But still, just look at the data, what they have given in the question. We know in summer, we used to take, see, first of all, in summer, whenever we are taking the data of temperature stresses, we need to take the values at summer, right? Warping stresses during summer. Similarly, frictional stresses during summer. So this data we need to consider first of all, right? Just a second. Yes, sorry, there was a connection issue. Yes. Now, the second thing is the data at midnight we need to consider. So midnight, always we need to consider the stress value at the corner point, right? At corner, whatever be the warping stress and whatever be the wheel load stress, that's what we need to consider. Okay, so here you can see, if you're closely observing, somewhere they have given C, somewhere they have given E, which is nothing but this E stands for what? Edge. And this I stands for interior. And this C here, I hope you are able to see it. Okay, this C stands for corner, right? So which value we need to consider? The value which is at the corner. So this is one combination we need to take. The second one is this combination, right? The warping stress as well as the wheel load stress at the corner. So which means option B will be the final answer. Even if you are not remembering this corner or whether I need to take at the edge, no issue. Since at midnight we are not going to consider frictional stresses, obviously option B is the only choice we are having. Understood, guys? So direct, very simple question, but lengthy data, very simply you are going to get that 1 mark. Right or not? So that's it. And moving to forward to the final question of the transportation engineering. It is asked from the traffic engineering chapter. What we need to calculate is the upper limit of the traffic sign. So this concept itself can be asked for 1 mark because the upper speed limit is nothing but 85th percentile speed, right? So this is what they are asking us to calculate, the 85th percentile speed. And we know how to calculate it, right? In classes also we have done it, lot of questions. First of all, we need to calculate the percentage, right? Percentage frequency. Here itself I am doing it. First of all, we need to calculate the percentage frequency. Then we need to calculate the cumulative percentage frequency. Right or not? Percentage frequency and cumulative percentage frequency. Percentage frequency means what? Each value we need to divide with the total number. But total number we don't know. No. Total number we need to calculate. So once you are taking all these 7 plus 31 plus 76 plus 129 so on, total you are going to get 500. That's it. Which means the first frequency will be 7 by 500 into 100. We are going to get it as 1.4 percentage. Similarly, second one will be 31. Okay, here I am writing 31 by 500 into 100. You are going to get as 6.2 percentage. Similarly, 76 by 500 into 100, you are going to get 15.2 percentage. So just so on we can do. I'm just writing the data here. I mean the value here, 25.8 percentage, 20.8 percentage, then 15.6 percentage, then 29 by 500 into 100. It's going to be 5.8 percentage, then 4.8 percentage. You can just compare your data with these values, whether you have made any mistake or not. And finally, 1.8 percentage. Right or not? Now what we need to do? The cumulative percentage frequency, which means the first one will be as it is, 1.4. The second one will be 6.2 plus 1.4. It's going to be 7.6. Now the third one will be 15.2 plus the previous value, 7.6. It's going to be 22.8 percentage, right? What is the meaning of this cumulative percent frequency? I hope you know that, which means we need to keep on adding, right? From this value, to this value, the previous value to be added, and to the other value, all previous values to be added, right? Like that, we need to keep on adding it. That's the meaning of cumulative. So for 25.8 corresponding to that, we are going to get 48.6 percentage, and corresponds to this, we are going to get 69.4 percentage, and corresponds to this, we are going to get exactly 85. Yes, this is what we require, right? The 85th percentile speed. See, if you are continuing, then of course you can do it, but not required in this context. Which means if you are doing it, it's going to be 90.8 percentage. And again, if you are doing it, you are going to get 95.6 percentage. I will tell you the reason why I'm telling this. Then again, if you are doing it, you are going to get 98.2 percentage. Then finally 100%, right? The reason why I told you this is we can just check whether our calculation got any mistake or not. Okay, whether our calculation is correct or not. This final value should be always 100. Suppose if you are not getting 85, exact 85 here, sometimes it can be some mistake, some calculation mistake. Okay, so you can also verify whether the final value is 100 or not. If yes, then your calculation will be definitely correct. Now, coming back to the point required here, we got 85th percentile speed. What is that? Corresponds to this. The speed range is 50 to 60. Now, if you are going back to the options, you look at here. In the range 50 to 60, we are having 50. We are having 55 also. Now, what to do? Obviously, this is not the right answer. This is not, because it's outside the range. In this range, which value we are going to take? This point also we have discussed in the class. Always, whenever we are having a range, it's the law of statistics. We need to take the middle value as the representative value. Enough. The middle value or mid-x, like that we call. Which means the middle value is what? 55 kilometers per hour. Option B will be our final answer. Got it, guys? So since it was an MCQ, it was very important. Otherwise, if it was an NAT type of question, maybe 50 to 60 like that, they may be giving the answer key range. But always it's a rule in statistics to take the mid-x as our representative value of the range. Okay, so here option B, 55 kilometers per hour will be our final answer. Okay, so I hope you got the concept. That's it. These are the various questions came from transportation engineering. As expected, a lot of questions asked. And I hope you have understood all the explanations that we have made in this video. And also, I hope this video will be very helpful for you for your preparations of your upcoming exams. Thank you.